Welcome to the first lesson of the CBNST. This is the computer-based numerical and statistical analysis. Before jumping into the subject, let me tell you what is the importance of this subject, what we study into this CBNST. As we know that this is the computer-based numerical and statistical analysis. So this is divided into two separate parts. One is the numerical analysis and second is the statistical analysis. So the importance of this subject comes where we need to overcome the limitations of normal numerical computations that can be implemented to practical applications. So there are not a lot of methods available through which we can solve every numerical thing, we can solve every statistical thing, and we fail. So where we fail or where the limitations are there for the formulas, we need to get into this computer-based numerical and statistical analysis. Let me give you a very simple example that if we the census, let's say the census happens after every 10 years, because it's not possible to have a census with lesser intervals, let's say in each month, in every month, or every year. It's not possible. So the census happens after every 10 years. Now suppose if you want to implement a policy in the year let's say 2025, so we don't have the exact population calculation of the 2025, because we have the exact calculation of 2020 and we will be having the exact calculation of the population in 2030, but we will not have the exact calculation of the population in 2025. So what we will be doing is we will be using the numerical technique to get the best approximation of the population in 2025. So this is all about numerical techniques. With the help of the numerical techniques, we want to overcome the limitations of the numerical computation. Second, we try to minimize the errors and we try to get the best approximated result. So this is the second reason why we use numerical and statistical analysis. Third, we provide methods for the best calculations. Yes, so we generate formulas and we generate methods to get the perfect calculation, the best approximated calculations. So these are the main three reasons why we need to study the numerical and statistical analysis. And there is one more reason, that is the fourth reason, obviously, to get the best approximated result. Right. So these are the four reasons we need to study numerical and statistical analysis. So let's jump into the syllabus, what we are going to study into this subject, what are the topics that we will be covering. So let me give you, I'll make it super simple for you, and you will be needing a scientific calculator so to perform all these calculations. So I'll suggest you, before going for the further lectures, just get a scientific calculator and practice all the problems. Rest, leave it on myself. I'll make it super simple for you. I'll make you understand in the best way so that you can score very high in this subject. So let's see what are the things that we will be covering into this subject. As I have already told you, this CBNST computer-based numerical and statistical techniques is divided into two parts. One is the numerical techniques, that is the part 1, and second is the statistical techniques, that is the part 2. So we will begin with the first part, that is with the numerical techniques. So in the first section, first we will study about errors and computer arithmetic errors. What we mean by the errors, why we study the errors, because as I have already told you, we need to get the best approximated result. I have given the example of that 2025. So that means we will not be able to get the exact population at 2025, but we can get to the nearest to the exact. That means removing the errors from that. So before we remove the error, we must know what are the errors that can occur into numerical computation. So we will be studying about the errors. Let's say what are the types of the error, what are the sources of the errors that can occur in numerical computation, And then we'll talk about the computer arithmetic. That means we'll talk about different numbers, significant numbers. Then we'll talk about the rounding off of the numbers. We'll go through with the rules of rounding off, significant digits, the sum of the numbers, floating numbers. We'll talk about the floating numbers, sum of the floating numbers, their subtraction, multiplication, and all such into the number arithmetic. So that will be required. So first we'll go with the errors and computer arithmetic. Then we'll talk about solution of algebraic and transcendental equations. Algebraic and transcendental equations are difficult to solve with the direct methods. Basically, we don't have a direct formula to solve them. Let's say if we have an equation with ax square plus tan x plus under root log x. So this is not an easy equation to solve. Such type of equations which has the combination of algebra, trigonometry and others, these are called as algebraic and transcendental equations. So we will learn the methods numerically to solve these type of complex equations. So in this we will be studying the methods. Some of the common methods that we'll study is the bisection method. We'll talk about regular falsi method. We'll talk about Newton's method, and we'll talk about some more methods with which we will be able to solve our algebraic and transcendental equations. So then we'll talk about solution of simultaneous equations. Yes, we have already done this solution of simultaneous equations with the help of the matrices, right? But there were some equations which we cannot solve with the help of normal matrices or normal solving those equations. So we have numerical methods, we have numerical solutions in which we will be studying the Gauss-Seidel method of solving simultaneous equations, and we will be studying Gauss-Jacobi method as well. So we will be studying these methods into the solution of simultaneous equations. Then we will talk about finite differences and interpolations. So in interpolation we have two types of interpolation. One is for the equal intervals and the other is for unequal intervals. Whenever we have the data with equal intervals, let's say we have the census in 1990, then we have census at 2000, then we have census as 2010, then we have census at 2020. So in all these we have equal intervals, equal gap of 10 years. So this is the first interpolation that is applied for equal intervals. For that we will have the methods, let's say Newton's method, Newton's forward method, Newton's backward method. We have Gauss's method, Gauss's forward method, Gauss's backward method, and we have Stirling's method, excuse me, and then we have the Bessel's method. So these are the methods that we study for equal intervals just to obtain the interpolation. And then for the interpolation we have for unequal intervals. If we have the data with different gaps, let's say if we have a data in 1995, then we have a data 2002, then we have data in 2007, then we have data in 2020. So you can see the gaps are not equal. In that case we need to apply other interpolation formulas, divided difference formulas. We will study Newton's methods, Newton's formulas, and we will be studying Lagrange's interpolations formulas for unequal intervals. Then let's talk about this numerical differentiation and integration. Yes, this is differentiation and integration, but this is not the normal thing. This is numerical differentiation and integration. If you get fear with this integration term, then let me tell you, there is nothing like performing integration. It will be very easy, formula based. That is why the numerical analysis and techniques are better, because here we have those formulas with which we can solve our integration problems even without applying the integration, right? So we will not apply that integration, the complex things of the integration. We have the alternative methods through which we can obtain our differentiation as well as integration. This sounds good because you don't have to apply that integration, right? Without applying integration, we will be finding out the solution, right? So this is numerical differentiation and integration, in which we will be learning the formulas like trapezoidal rule, Simpson's rules are there, Simpson's 1/3 rule, Simpson's 3/8 rule, then Webbe's rule and Euler's Maclaurin's rule. So we will be learning all these methods, all these formulas to find numerical differentiation and numerical integration. So these are the numerical integration formulas. Then we will be talking about solution of differential equations. Yes, if you remember the differential equations that contains dy by dx, d2y by dx square, d3y by dx cube, df upon dx dy. So these equations which contains these terms are termed as differential equations. If you remember, we have lots of methods, lots of different forms, cases to solve these differential equations. But now we don't have to learn about all those cases. We don't have to memorize those cases. We will simply using direct methods and we will be solving those differential equations. So for that differential equations, we will be having Taylor series method, Euler series method, and then we will be having the RK method. So these are the major methods that we will be using to solve differential equations. So this was the first part of the CBNST, that was the numerical techniques. Now we will be turning to the second part of this subject, that is statistical techniques. In the statistical techniques, first we will study curve fitting, in which we will be talking about method of least squares. This is one of the very important concept into the statistics, with which we will be learning about how we can fit lines, fitting of lines and fitting of parabolas of higher degrees as well, of the second degree as well. So we will talk about fitting of lines and fitting of parabolas. Then we have time series and forecasting as our next chapter, as our next topic, in which we will study moving averages and forecasting models. So we will be talking about moving averages and forecasting models. And lastly, we have testing of hypothesis. Yes, this is a very important subject in reference to the research. If you want to go for the research in future, then this testing of hypothesis is very important topic for you, because you need to test your hypothesis that we form in our research. So we will be doing the test of significance, and for that we will be learning the t-test, one of the very important and common method, f-test and chi-square test. So these all three tests are very important if you want to go for the research and if you want to do your hypothesis testing. So these tests, you must learn these tests, t-test, f-test and chi-square test. And in the last, we will be talking about analysis of variance. So this is all we will be discussing in our coming lectures, in our coming lessons, and just give me the time, just give me the power. I'll make this very simple for you. I'll make you learn and score very high in these subjects. So thank you for today's lecture. We'll meet to the next lecture. Thanks a lot.